We're going to look at 403, notes about ellipses. And an ellipse, we talked about last time, is one of the four conic sections. And it is when you slice a cone diagonally through the cone. So I have my manipulatives with me today. So I wanted to just show you what I talked about last time, those four types of conic sections. So here is the first one that we talked about yesterday. It's a circle. So remember I said it's by cutting the cone parallel to the base. See how that's parallel to the base? And when I show you the cross section, it's going to make a perfect circle. So that was circle. And then ellipse, I had said last time, we're cutting the cone diagonally, but not through the base. So see how that's being cut diagonally? And see how that forms an ellipse? So that one was diagonal, but not through the base. So that's what we're going to talk about today is the ellipse. And then I wanted to just show you, the next one I had shown you was the parabola. And the parabola was diagonally through the base, which is this one. So see how that's being cut at a diagonal through the base, and we've got your parabola. So the only thing that makes this one different than the hyperbola is this one is the hyperbola, and it has to be cut directly perpendicular to the base. So it still forms a similar shape as the parabola, but the parabola is diagonal through the base, and the hyperbola is perpendicular. So if you had set another cone directly above, so you'd have two inverted cones like this slice would continue all the way through the other cone. So because it's two cones on top of each other, it has to be perpendicular to the base to hit the other cone in that way. So we're going to look at ellipses today. There are four definitions for conics, and so a circle that we looked at yesterday is a set of points that are all equidistant from a central point. And I didn't define it yesterday that way, but a circle is, so circle is a set of points that are all equidistant from a center point. So I'm going to keep repeating these definitions, and I'm going to keep repeating the four types of conic sections each day just to get that familiar to you. But the definition of an ellipse is, it again is a set of points, but this time the sum of whose distances from two fixed points called foci is constant. That is quite a mouthful that I'm going to unpack for you using a bunch of definitions and formulas. But first, I'm just going to jump to problem 1 on the back, because I want to review again how to do that completing the square strategy, this time for an ellipse, and I want to show you how the equation gets graphed, and then we can unpack it on the front page. So just like with a circle, we want to start by grouping together our like variables. So 9x squared plus 90x